Good morning. We have to thank Paul for a lot of stuff. He told us about axioms. I can use some of them. Maybe I don't agree with all of them, but that's what they are for. And maybe I can add a few. A friend of mine, some time ago, he said to me, Niels, I've seen on your website you talk about zero defects. Now I have this new team, and can you teach them about zero defects? So we had a Skype tutorial through Skype, and I talked about this, and I made this story. So I thought, if he thinks this is useful, and these guys think it's useful, maybe it's useful for other people, so let's present it on some conferences. So here we are, and you can download the presentation with annotations in a handout from my website. Do we deliver zero defect software? Is zero defect software possible? Who thinks yes? Who thinks no? Okay. There's work to do. I can prove that it is possible. Accidentally, there could be no bugs, right? So it's possible. So how many defects are acceptable? How many? One? One is acceptable? Okay, one is the software doesn't work. That's acceptable. Yeah? Huh? Okay, so I'm sure because your developers produce defects, I'm sure your requirements specify how many defects they should inject, right? Because they do their best to produce the value of the requirements, and they produce defects, therefore, I'm sure they're in your requirements, are they? And as testers, you check whether they deliver the right amount of defects, right? Do you do that? How many defects do your requirements specify? Anybody? Have you seen them? No? So why do they make them? Isn't it weird? So how much time is spent in putting them in? And how much time is spent in trying to find and fix them, as if you can find them all? Any idea? About 50-50? Yeah? Give or take a little bit. Do you ever get repeated issues? Yeah, you get some issue, and sometime later you get a similar issue. Yeah? Who says yes? Oh, you're very bad testers. The first time, it's the developer's fault. The second time, it's your fault because you didn't help the developer never ever to make a similar defect anymore. And you forgot to do that. So how much time is spent in your projects on defect prevention? How much time? 0? You love to get more defects because you're afraid otherwise you lose your job? Oh, don't worry. So this is a picture I saw at the software conference of a large electronics company in my country. Interesting picture. First part, injecting the defects. Second part, trying to find and fix them. Oh. It was this company together with the university, and this was their process. And in the middle they say code is complete. How can you call it complete if it doesn't work? I was in a conference in Bangalore, in India, and from a large software company most people have heard of, somewhere in the northwest of the US, yeah, they had a similar picture. In the same slot after me in the conference, there was this guy, and this was their process. First half injecting the defects, second half trying to find them, fix them. 2 years later, I was in Portland, Oregon at a software conference. Guess what? In the same slot after me was a guy, a different guy from the same company. Same picture. Is this the picture of your software development? I think something is wrong here. But first, before you stop listening, because most people stop listening when I talk about zero defects, because they say that's impossible. You're coming from Mars. You don't know anything about software development. I'm not a tester, so I don't know anything about that. By the way, who is a QA person? Okay. Who is a tester? Who is doing QA apart from testing? Okay, thank you. QA is much more than testing. And my message is that the testers should learn more about QA, because your job should move in that direction if you want to keep a living from testing. From QA. But before, let's talk what Zero Defects is. Zero Defects is not turning a knob and suddenly we don't make defects anymore. That's not what it is. Zero Defects is actually an asymptote. An asymptote is a line that you never touch. You go there. This is what we call the learning curve. Yeah. And with the learning curve, you learn better to make less defects, prevention process, and you go to the acceptable level. Now, if the acceptable level is 13 errors per 1,000 lines of code, well done. That's the industrial average. Good job, developer. Is that what the users want? Did they order so many defects and you have to deliver them? So the only way ever to get near zero defects is to have it as your target. Then only people may get near. It's an attitude. Zero defects is an attitude. We are not going to make defects anymore. And please, testers, you look differently at what we make. Tell us what we are not yet perfect on. You see things we don't see. Please help us. Testers are consultants too, etc. When Phil Crosby started with Zero Defects in the 1960s, errors dropped almost immediately by 40%. I did the same in a software project. I didn't believe it, just like you. I didn't believe it. I said, let's try. So I was in this software project and I said, guys, from now on, I don't want to see defects anymore. It took about 2 weeks for them to find out I was dead serious about it. I said, if you want to know how to do it, we can talk about it. Yeah. But after 2 weeks, in the third week, the testers were working in the corner there. And they came to me, they said, Niels, something weird is going on. We don't find defects anymore. Now that is cheap. Just changing the attitude costs nothing. Well, a little bit for me, but it costs nothing. And suddenly, these developers are very well capable of producing hardly any defects. But we never ask them. Who is counting defects? Nobody's counting defects? Be honest. Who is not counting defects? Oh, about 40, 60. Okay. Never, ever count defects. Because if you count defects, you send a message to the developers that they have to produce them. Because if they don't produce them, you cannot count them. Yeah. Phil said, an AQL, acceptable quality level, more than 0, means that the organization has settled on a level of incompetence. How about that? We accept a certain level of incompetence. Causing a hassle other people have to live with. Now, I don't know whether you know what the word hassle exactly means. I had to learn it because I'm not native English. Yeah? But I started liking the word. A hassle is causing a problem to the users. To me, the definition of a defect is something that causes a problem to the user. All the other defects are no defects if they don't cause a problem. So don't waste your time on them. So causing a hassle. And I found that if I use with developers, make zero defects, they don't know how to handle it. And I found that if I use, especially in English-speaking places, yeah, I said, no hassle. And they can feel what that means. They can feel they're creating a hassle, a problem to the users or not. And there's Phil Crosby. It's a nice book. He said, and now we come to the axioms, but he makes it even stronger. He said, this is not just axioms, these are absolutes of quality. Not even to question. Conformance to requirements, and if the requirements aren't correct, we change them until they are. And that's, he's not just talking about the product requirements, but also the work requirements, how we work for our customers. We don't produce defects. And it's obtained through prevention. That's the only way how to do it, not making them. Somebody else, a Japanese quality guru, said, the error that is not made cannot be missed by testers. And the performance standard is Zero Defects, and it's measured by the price of non-conformance. It's not just the price of testing, the cost of testing. The first testing is still necessary, because we know we are not perfect. But then, if you find a bug and it has to be repaired, has to be retested, it's all waste. Yeah? And if it results in a bad name of your company, that's the highest cost. So the price of non-conformance is huge compared with your price. And later, he's dead already, but his company added a fifth one. The purpose is customer success. Now, I agree with that, but I don't like that they added on their poster, not customer satisfaction. They used that because most people said quality is customer satisfaction. So actually with this small sentence, added sentence, they mean it's not just customer satisfaction, it's customer success. Look over the shoulder of your customer and see what he needs to be more successful. And that's how I come to my top level of any project of the work we do. Delivering the right results at the right time, as efficiently as possible. And efficiency to me is effectiveness plus time. I call it quality on time, I can't make it shorter. The right stuff at the right time. And a little bit longer, I say providing the customer, through the users, with what he needs, which is not what he says usually, at the time he needs it, which may be earlier or later than he says, to be successful than he wants to pay, to be satisfied than he wants to pay, and to be more successful than before. If he is not successful, he cannot pay. If he's not more successful, why would he pay? You know those software projects that deliver nothing and collect a lot of money? Well, some people say, well, we delivered. Well, if it doesn't work, you delivered nothing, of course. But the customer is not king. Well, they are king, sorry, but we are not slaves. So it must be win-win. And what the customer wants, he cannot afford. You recognize that? So if you start making what the customer wants, we are going to fail from the beginning. So we must have a good view on what the customer can afford and what we mutually, beneficially and satisfactorily can deliver in a reasonable period of time. Maybe difficult English words, but every word is very carefully chosen. And if you can improve, please do. So I use this as the top level requirement of our work. And everything we see people doing that doesn't support this, we ask, why are we doing this? Who is waiting for it? Now, one thing about prevention. Who knows root cause analysis, the concept of root cause analysis? Who knows the concept of cause analysis? There's a difference. In your organization, do we routinely do root cause analysis? Well, if you don't know what it is, then we have to discuss. Okay. The cause of a defect is the error that caused the software not to do what the user needed, causing the problem. But the root cause is what caused us to make this error that causes the problem. And many people confuse these two. They say the root cause of the error, of the defect is the error. No, the cause is the error that caused the defect. The root cause is what made us do it. And that's what we are after. Because only then, if we recognize what we did to make this error, we can learn not to make the error again. That's why root cause analysis should be done. And when I asked in a project manager and architect, do we do root cause analysis always? On every bug, they asked. We don't have time for that. Well, then we have to keep doing them. Because without proper root cause analysis, we are doomed to repeat the same errors. Remember? You saw them once, you saw them twice, you see them more time. The first time it's their problem, the second time it's your problem because you didn't help them to do the root cause analysis and make sure we never do it again. That's the first purpose of testing. Testing is not to find bugs because they shouldn't be there. Yeah? But if they are there, we must feed back in the prevention process. That's your first function. So what has to do with this? This is all developers, right? But we are testers, and a few are QA. Hopefully later a few more are QA. So, but I mix the words. I mean, in software, most people say if I talk about QA, they think testing. So I take the liberty to talk about testing and issue it's QA. Yeah, why not? So what's the goal of QA in a software development project? Do you know? I think Paul asked a similar thing. What's the purpose of QA? Who is your customer? Do you know? Paul also asked that. Who's your stake? Who is your main customer? Any idea? People. Huh? Yeah, of course, people. We're all people. Machines don't care. Somebody who is going to use our system for the business. I'd like to have another answer. Paul said it, and I think I already said it. Now, I have a quote from Dr. Deming. He was also dead, but he's, together with Phil Crosby, he is the quality guys. Everything after that about quality is based on what they already said. And Dr. Deming said, quality comes not from testing, but from improvement of the development process. Testing does not improve quality nor guarantee quality. It's too late. The quality, good or bad, is already in the product. You cannot test quality into a product, right? So, who is the customer of testing? The developers. They are the only customer. Because they put the quality good or bad in. And they should put the quality good in. And you are there to help them. And now we can think, once we have identified our main customer, now we can think, what does our customer need? And that's not what he says. What time does he need it? Which may be earlier or later than he says. And he must be satisfied and more successful than before. Because if he's not more successful, testing is waste. Because it is. It doesn't contribute any value. The developers are the only people who put the value in. So why are you there? As consultants to development to help them to do an even better job. So if you don't have a good focus of who your customer really is, how can you do a good job? How do you know who's paying your salary? How do you know you've done enough? And as a consultant, well, I'm not a consultant, I'm a coach. Yeah? As a coach, I always tell the guys, the quicker you get rid of me, the better I did my job. Or the worse I did my job. That's also possible, if they kick me out. Yeah? So also, if you are a consultant, you should do such a good job that testing is not anymore necessary. And as I said, you don't have to be afraid, because it will take some time. Yeah? But there is so much software in the world that we have to make and still have to make. So don't worry that you won't have a job. Just do the good thing. Yeah? Now, some people maybe remember the W model. It came from the waterfall, and some people say that's wrong. It's not wrong at all. First think, then do, and then be happy. Yeah? Only you should do many times, because if you do it only once, we are in trouble. And we have the V model, but then the testers came and they said, let's not just do that, but let's test the requirements. Let's test the specification. Let's test the design. And then do the testing of the code, of the working. The earlier you test, we don't want the bad things in the requirement to pollute the next stage. We don't want the problems in the specification to pollute the next stage. What's the point in testing the implementation if there is shit in the other part? Yeah? How many people don't see any requirement? Some of you. Now, testers, if you ever see no requirements, there is only one bug, that the software was made, because it was not required. Very simple. Yeah? No requirement, nothing to develop, nothing to test. There's only one bug, they made it. Very simple. So, a few examples. We don't have much time, but we are not perfect, but the customer shouldn't find out. That's the basic idea. Yeah? So what do we have to do between those things? We are not perfect, but the customer shouldn't find out. No hassle. Yeah? And the more we have to do in between, the more we waste time. So how quickly can we learn to do things first time right? Much better than we think. Well, the basic idea is design. If I use the word design, many people think about fashion, nice clothes. Or I was in Serbia in a software company, asked, do you have a design? Yes, he's doing design, user interface design. I said, no, I talk about engineering design. Are there in your company software engineers? Or software people? How many of your software guys are trained in engineering? Many or not so many? So we have to go back to engineering, teaching them engineering. I happen to be an electronics engineer, and if you design electronics, it should simply work, especially if you repeat it a million times. So the basic idea is design, review until you're happy, then code and review until you're happy, and then test doesn't find anything. Every time we do this, this works. Every time there is no design, we reconstruct the design and they find the bugs that have been bugging them for years. Yeah? And then I gave to you a simple mantra to tell as a requirement to your developers, if you deliver anything to us, one question or one issue, bug. Abort. Don't waste my time. How about that? Teach him a lesson. If they give you something, if you have one question to ask, I mean, once the software is out there, there's no question to ask because you're not there. And the developer is not there. The computer has to solve everything on its own. So the moment the user has one question, there's a problem. The moment there is any defect, there is a problem. So if what's the effectiveness of testing? How much do you find? About 50%? Who's more than 50%? Who's less than 50%? About 50%. Okay. Yes, thank you. Now, assume it's about 50% plus or minus 30. Your effectiveness, what you find. You test only a sample, so Anyway, it means that if you find one bug, the customer will find one. If you find two, the customer will find two. That's the meaning of this statistic. So the only way the customer has no defects is that you don't have any. You still don't know that they really are not there, but at least you are in the good direction. The moment you find one, you're in a worse condition. And then we say, if there is still an issue found or a question to ask, no band-aid, we start all over again. Throw away your code, start designing again. This is what they did in the 70s in the clean room approach to software development. In the clean room approach of software development, unit testing was not even considered economical. It cost more than it gave back. No return on investment of unit testing. Can you imagine? All these guys doing unit testing, if they do? Waste. So go back to your design. And if you test something and you go to your developers and you ask, can I see the design? How many people get a design? Okay. How many don't? Okay. Happy few and the others. So if there is no design, reconstruct it. That's what I do with these guys. And within 10 minutes, they found these bugs that have been bugging them for years. And in a week, it's gone. And some people think I'm expensive. The case in the pub. I talked it yesterday, but there are other people here, so I thought I'd still repeat it. I was in a company in Dublin, and I was asked to help them with some requirements because this team didn't know the goal of their project. So they asked me, can you help them to define the goal of their project? Some requirement thinking. And in the evening, they had their pub day. Every month, on Thursday, they had their pub day, had drinks and food and nice talking. So they said in the evening, come with us to the pub day. So we were in the pub, and James, the quality manager, he brought Louise here and said, Niels, this is Louise. Louise, Niels taught me design logging, how to design in my previous company in Dublin, and tell what happened. And he left. So Louise said, we had only 7 days to finish some software, my team. So we work hard, coding, testing, coding, testing, coding, testing. Recognize? Yeah. So that's some picture I found on the internet, and that's absolutely wrong. And James knows that, so he said, stop coding and go back to your design. Yeah, but we don't have time. Only 7 days. We don't have time to go back to the design. We have to code and test. He said, you stop coding, go back to your design. Apparently he came in this company at the level that he could say, you stop coding, go back to your design. So she did that. They designed, found the problem, corrected it, cleaned up the mess of the coding, testing, all the scars, and they were done in less than 7 days. She said, thank you. But then I put that on my webpage. You can find it somewhere on my website. Yeah. And I sent a link to James. I said, James, I think this is what she said. Can you check with her? And then came back the message, you know, it was much more interesting. I gave the design to 2 colleagues for review. Design, then review. When Louise heard it was going to review, she said, yeah, then I have to do a better job. I didn't know you were going to review. He said, well, you did your best. Let's see what happens. So it was reviewed, and people without review education, without review training, find hardly anything, so maybe a few typos, and then she corrected that, and they did the final review. But in the final review, there was another colleague, and he spotted something that would be getting really bad, so he said, we have to redesign the whole idea, which they did. That's what they built. But it was even more interesting. There were 2 modules this team had to deliver in 7 days. One they did this way, and the other they did their old way. And guess what happened? The one with the design simply worked. The other one, full of bugs. Every time I do this with people who have been having bugs for years, in 10 minutes they find them just on the whiteboard, sketch it. Yeah, thank you. And then in a week it's gone. So even if you don't believe this, how about trying it? I didn't believe it. I tried it and it worked. So he said, from now on, we do design logs here. First design, review until happy, code, review until happy, testers don't find anything. Do you want to find nothing? Otherwise you're not a good tester, are you? Now, how about design? You can do design in many ways. In text, that's useless. We cannot make a model out of text easily. And everybody makes a different model out of text, so that's not good. So I found in one document this nice picture, because I said I want design, and he made this picture. Well, you can make a design in 100 ways, but only few ways are in such a way that somebody else immediately spots a problem. So it looks very scientific, yeah? So I thought, let's clean it up a little bit. This is the way how I would do it. And once I did that, not that my picture is better, but by doing it, I had to rethink every line there. Is that really what it is? And suddenly I saw, I'll try to show it here, that you see it on both screens. If you look at this, if you can read this, it says if n is not equal or n is equal to. So that means it's either this or that output, which means it never goes to, can I do this? Here. Yeah. So by reviewing it and showing it in a way that reviewers immediately see these things, yeah, you get your feedback before you implement it. Okay. So there was this unit that controls air conditioning and lighting and so, and in your hotel room you may have such a little thing. Now in this case, why? Let's not talk about that, but in this case they wanted the people who installed the air conditioning to tune the air conditioning for the room through this little device with a few knobs and the display. And nowadays it's maybe easier to do it with a phone, but this is how they wanted to do it. And some designer made these pictures. You recognize pictures like that? Absolutely useless. Yeah? He made 47 pages of these kind of pictures. And because that's a lot of copy-paste with a little changes, absolute inconsistent. And everybody who starts reading after 5 pages, they stop reading. Yeah? So it's useless. So I looked at it. That one is from Ireland, that one is from Switzerland. So the Swiss started to read and stopped after a few pages, and they made their own document of their interface, how it should work. And then the documents were lying there, and they were waiting until everything was done to connect them. Well, I read this document, I read that document, I say, if we connect it, it won't work. So let's analyze a little bit more. This is my picture of 47 pages, one sheet. I discussed this with the engineers in Ireland. Then I went to Switzerland. I discussed it with the engineers there. And we added or modified a few things. It's not important what's exactly there. It's just one way of representing. It's a state machine, yeah, how you step through things. And on the train back from Switzerland, because I had nothing to do in the train, 3 hours in the train, so I thought, if we implement that in our Ireland piece, yeah, how would it look like? Can I implement the things we had been discussing in Switzerland in some way? And this reflects what this clean room approach of software development did to make a level of 10 times less defects routinely in less time. So why don't we know that anymore? Thank you. So I sent this to Switzerland. I said, this is what I think we have to do. You have to connect this. Yeah, it goes on the top. We get a message from you and what happens. What are the things that can happen? And they said, oh, it looks okay. And within half an hour, I found a defect myself. So you see, untrained reviewers find hardly anything. It seems okay, but you have to be trained how to read this, even if I think this is a good way. But maybe I'm wrong. Basically, don't believe anything I say. Okay, just to make sure. I sent this to Ireland, and I didn't hear anything. It was my last day there. Next week I'm going back after 2 years. Maybe they need me a little bit. So 2 months later, I asked, did you use anything of this? Because, well, it was my hobby, but was it useful? Yeah, we just implemented it. It worked. Yeah. So Clean Room says we design up to about 3 lines of code. So deep. This people can follow. Normal people can follow with a little bit help. Code, nobody can follow. Yeah. So do you ever review software apart from testing? Who reviews software? A few. Who does not review software? Oh, you're fooling me, but we don't have time to do the statistics better. What do you get if you ask to review software? What do you get? Okay, this something like that? Yeah. Do you see structure there? Well, some structure and some coloring. But do you really see at one glance what's happening? Yeah? So what is better than reviewing code? Well, by now you should know. Yeah, may I see the design first? Because if people send me code, I say, I can review that, but what's the point? I'm not wasting my time. Because the moment we review the design, the code will change so much that I just wasted my time. Yeah? And what you see developers do, they sit on this screen and they look at this, but they see only these little pieces. And you see them switching screens. Yeah, this is what happens there. And you know why they do that? Well, they have a poor brain there. And in this poor brain, because they don't have a design, of course they need a model in their brain of what the system should do. But in our brain, this model fades away all the time. Yeah? So they have to constantly refresh it by going through these screens. And at the same time, the other side of the brain has to think now what to do with the model to make better code. Now, if you put it on paper or on a whiteboard, it's out of your mind. It doesn't fade away anymore. Other people can see it and help you to see the flaws in it. And you have your whole brain ready for thinking to put the model into the code. How about that? So this is 1985, very old stuff, but this is a simple thing to keep a PC working when it is hanging there with a big screen in the airport. Yeah? If it stops, blue screen and things like that, that it automatically, as much as possible, gets revived automatically. Well, it took me some time. First, of course, I started coding. I'm not better than developers. But then I said, Niels, don't do that. Yeah? So I said, what should I do? And this came out. And can you imagine that anybody in his mind can keep this model and code it correctly? I can't imagine that. And then from there, I got flows. And from there, I made code. And this is about the same. Can you see structure in that code? How can they? I won't give you the example, but give you the entrance of, because it's, again, the no questions, no issue. Who's doing Scrum? Okay. Do you have a Scrum review? Some people call it demo. Never, ever demo again. It's useless, isn't it? Okay. So I said to the Scrum team at the Scrum planning, I said, what's your definition of success? Don't you know we're agile. We deliver some working software. I said, no, what's the definition of success? Because if you switch on the computer, it already runs software. Now, there are ones and zeros in the memory, so it runs. But does it do what it should do? And does it not do, I know, I take a few minutes. Yeah. Does it not do what it should not do? Yeah. So I said, let's make as an easy requirement for your success, no question, no issue. Accidentally, they succeeded. Download my handout and you can read the story in the annotation. First they said that's impossible. I said, you're a clever guys. Simple requirement, no question, no issue. Yeah, but how do they know? You'll find out. And they did, accidentally. So, to finish for why is a demo so bad? Yeah. If you keep it, calling it a demo is okay. But the demo is, stakeholder, what do you think? Do you think this is nice? Oh yeah, it's nice. But why is that color yellow? Shouldn't it be blue? So if you get a boring demo, they ask boring questions. Yeah? So instead of that, give it to the stakeholder, handcuff your hands on your back, zip your mouth, and observe. Because once the software is out there, you are not there to handheld the computer. It has to do it by itself. So seeing what the stakeholders actually do, this gives you the right feedback you need. Is that what you do in demos? Who does? Who does not? Just be honest. Okay, so just a suggestion. Yeah. So I have no time for this. You can read that. This is the basic idea I added. Yeah? Design the requirement, review the requirement until you understand it well, design the implementation, review it, implement, review, and the testers don't find anything, and that's what you want. And that's what QA is about, helping them to do a better job there. Helping them where they're not yet perfect. Better quality costs less. Some people, this iron triangle, time, budget, and quality, bullshit. Yeah, bullshit, that's my stamp, a bullshit stamp, if I hear these strange things. And later I only have to do this, and they know. And they start repeating bullshit. Yeah? Better quality costs not more. And why does it not cost more? Bad quality, testing, finding, and doing good quality. 3 times as much as doing it right the first time. Right? So you have a huge budget to do the improvement. Okay. That's it. Any objections? Don't have? Okay. I'm here until the end of the day, at least.